Hi, I'm Milind, and in this video we will continue our discussion on how to find the factors of quadratic expressions. So the quadratic expressions that we discussed were of the form ax square plus bx plus c, where a, b and c are the numerical values which we saw. For example, in 2x square plus 5x plus 2, a is equal to 2, b is equal to 5 and c is equal to 2. So this is the standard form of a quadratic expression in one variable. And then the standard form is such that the order of the terms are decided by the descending power or degree of the variable. So if you see, the first term is ax square, so x raised to the power of 2, and bx is x raised to the power of 1, and c is actually multiplied by c into x raised to 0, and because x raised to 0 is 1, we don't write it. But what if you have quadratic expressions like these? Do you see any constant term here? You don't, right? So now we are in a fix. The technique which we found, would it work here? So what are these types of expressions? I mean, this is a standard form of quadratic expression in two variables, x and y. So the standard form is ax square plus bxy plus cy square. And if you see, the order of the terms are decided by the descending power or degree of one of the variables. Like here we have decided that we will take the variable x and then arrange the expression in the descending order of the power of x. So x square, then x raised to 0. So now can we find the factors of x square plus 8xy plus 15y square using our technique? We really don't know because we don't have a constant term here, right? So what we will do is we'll try to find out the factors using our practical method and then try to see how we can fit a technique for that. So now there is some change in the way that we name the units of the rectangular and square shapes. So the square shape, which has sides as x units and x units, remains the same. The rectangular shape would have a side of x units and y units now, because we want rectangles having area xy. And then the one unit becomes y into y. So the area of the bigger square is x square, the area of the rectangle is xy, and the area of the smaller square is y square. And how many pieces do we need of each one of these for solving this expression? We need one piece of x square. How many of xy? We need 8 pieces of xy and 15 pieces of y square. And again, you know now what we need to do. We just need to arrange this in the form of a big rectangle and try to find out the factors. So can you try it out? So this is how we have arranged it. So if you see the 8xy, the way it has been split as 5xy and 3xy. So measuring the length and the breadth, we have x plus 5y and x plus 3y, and these are the factors of the quadratic expression. So what are your observations here? The 8xy has been split as 5xy and 3xy, and the 15y squares have been arranged as 5 columns and 3 rows. So now can we apply the technique here? So x square plus 8xy plus 15y square becomes 8x square plus 5xy plus 3xy plus 15y square. And then again, as before, we make the two groups, the first two terms and the last two terms, and then try to find out the commons between them. In the first group x is common, and in the second group 3y is common. Then we arrive at the factors. So if you see, the factors which we arrived at using the technique are the same as the ones we arrived at using the practical method. Isn't it simple? So what did we do here? So in our previous examples, was the variable y present? Just think for a while and see and check if y was present or y was not there at all. And I would say it was present. How? It was present, but its value was 1. So when y becomes 1, the expression x square plus 8xy plus 15y square becomes x square plus 8x plus 15, which you have already solved. So it's not that you are trying to solve a totally different type of an expression. You are still trying to solve the same type of expression, but with some small changes. So similarly, I would urge you to try to find out the factors for the expressions that are shown. And write your observations. In each case, write your observations. Try to solve this using the practical method, then try to solve it using the technique. And then let us see what we get. So now, can you define a more refined technique? Try it out. And then you can continue with the video. So now, what is a more refined technique for the split? You'd say write the quadratic expression in standard form. So this is the new thing which has come in, because we knew that there was a constant term in our previous examples, but now since the constant term is no longer there, we cannot say that multiply the constant term with the coefficient of x square and so on. So what we say is write the quadratic expression in the standard form, take the product of the coefficient of the first and the last term. The first term would be the coefficient of x square and the last term would be the coefficient of y square, and then find two factors such that the addition of the factors gives the coefficient of the middle term. Correct? So there you are. So this is the way we try to solve quadratic expressions and find out the factors. So let us try out the technique on one of the examples. One of the examples we have is 2x square plus 5xy plus 3y square. So what did we say? Is it arranged in the standard form? Yes, it is, because one of the variables, which is x, we have arranged it in the descending order of its powers. So x square, then x raised to 1, then x raised to 0. X raised to 0 we don't show because x raised to 0 is 1, and anything multiplied by 1 is the same number or same expression, so we don't show the 1. So we take the coefficient of the first term, take the coefficient of the second term, and then multiply it to find out the value of the product. And then what do? We find factors of this product. So factors of 6 are 6 and 1 and 3 and 2. And which is the one we will choose? We have to see the middle term for that. So 5xy. So which of these factors gives us an addition? The addition of which of these factors gives us 5? 3 and 2, right? So we split 6 as 3 and 2 and then add them to get 5, which is the coefficient of the middle term. So if we had to solve this expression, what would we do? We would write the expression as 2x square plus 3xy plus 2xy plus 3y square. And then again, as before, we would go group the first two terms and the last two terms, and then take the common and find out the factors. Now I think you are pretty comfortable with the technique, right? So the more standard way of doing this, or the way you are taught in the school, or the textbook way of doing this, is something like this. So the expression is 2x squared plus 5xy plus 3y squared, which is the same as the previous one. And then instead of taking the coefficients, we take the whole of the first term and the whole of the third term. So 2x squared and 3y squared, and we multiply that to get 6x squared y squared. And then we have to find out the factors of this 6x squared y squared, whose addition would give us 5xy. So what would be the factors? So 6xy and 1xy, or 3xy and 2xy. So we would choose 3xy and 2xy, because the addition of that would give us 5xy, which is the middle term. And then again, we just split the middle term, take the common values, and then find the factors. So simple, right? So now you have arrived at a technique for finding the factors of quadratic expressions. Now you no longer need to use the square pieces or the rectangle pieces, because once the numbers start becoming bigger and bigger, like instead of 5 you have 11 or 20 and such bigger numbers, it will be very difficult for us to really use the practical method, because we need so many more pieces of the squares and the rectangles. But you have understood this, right? A very simple technique, and once you have thoroughly understood this, then you would be able to solve any quadratic expression and find the factors of that. So I hope you are very confident now. You would be able to find out quadratic expressions on your own using the technique. So find out all the examples which you have in your textbook and try to get the factors. But the question is now, what if negative signs are involved? So you could have an expression like x squared minus 8x plus 15, x squared plus 6x minus 16, 2x squared plus 5x minus 3, 2x squared minus 5xy plus 2y squared. So what do you do? What would you do if you have negative signs involved? Try to see if you can apply the same technique and find the factors of these. So again, like before, I will give you some hints for this. So hint 1 is take the first term and the last term along with their signs to get the product. So you already know that if a plus is multiplied by a plus, you get a plus. If a plus is multiplied by a minus, you get a minus. And if a minus is multiplied by a minus, you get a plus. So find the product by using the signs of the first and last term. The second hint would be find the factors of this product such that their addition is the middle term. And here by addition I mean you have to use it along with the sign. So if you add minus 2 and 1, what would be the answer which you get? You would get minus 1, right? So that way. So see you in the next video. In the next video, we'll try to understand how to deal with the negative signs. But till then, I would urge you to try it out yourself and find out how to get the factors.